Welcome to question 4 from the 2020 CTMUA, paper 1. The question tells us that the first, second and third terms of a geometric progression are also the first, fourth and sixth terms, respectively, of an arithmetic progression. We are told that the sum to infinity of the geometric progression is 12, and we are therefore asked to deduce what the first term of the geometric progression is. The options we are given are 1, 2, 3, 4, 5 and 6. Pause the video here and have a go at doing this question for yourself. Okay, let's begin by thinking about the general form of a geometric progression. A geometric progression has a first term, which we'll call A, and then a common ratio between its terms, which we'll call R. So it looks like this, where the first term is A, the second term is A times R, then we multiply that by R again to get to the next term, which is AR squared, and so on, and the nth term therefore has the form a times by r to the n minus 1. What about an arithmetic progression? Well, in an arithmetic progression, we're adding on some common amount each time to get from each term, so we'll call that amount d, and since we know the first term of both progressions are the same, we will start from term a, and therefore our arithmetic progression is a, then a plus d, and then adding d onto that again, a plus 2d, and so on, so that our nth term is a plus n minus 1 times d. So now that we have our information represented like this, we can write down mathematical statements to show that the second term of the geometric progression is the fourth term of the arithmetic progression, and that the third term of the geometric progression is the sixth term of the arithmetic progression. So indeed, the second term of the geometric progression is a times r, and the fourth term of the arithmetic progression is a plus 3d, so these two are equal, and the third term of the geometric progression is a times r squared, and the sixth term of the arithmetic progression is a plus 5d. So we have these two equations with the unknowns a, r and d. So let's call these equations 1 and 2. And now how can we use the piece of information that the sum to infinity of the geometric progression is 12? Well, we have a formula for the sum to infinity of a geometric progression, which is a times by 1 minus r, where a is our first term and r is our common ratio. And this is only true if the value r is between minus 1 and 1, if its absolute value is strictly less than 1, because otherwise the sum to infinity doesn't exist, because the sum diverges. So now that we know that the sum to infinity is a times by 1 minus r, and it's also equal to 12, we know that those two things must be equal, and we'll call this equation 3. So these are now the three equations that we have for our unknowns. So what can we do now? Well, we can try to rearrange our equations in order to solve for some of the unknowns. So if we look at equations 2 and equation 1, we can try to eliminate the variable d if we multiply equation 2 by 3 and equation 1 by 5 and take the difference of them. Then we'll have 15d on both sides, which will cancel out, and from the other parts of the equations we're left with 5 times ar minus 3 times ar squared is equal to 5 times a minus 3 times a, so is equal to 2a. And equation 3 tells us that a is not equal to 0, because if a equals 0, then we would have 0 equals 12, which doesn't make any sense. So we can divide through this equation by a, and we're left with 5r minus 3r squared equals 2, which we can rearrange to get it in the usual form of a quadratic equation. So we have 3r squared minus 5r plus 2 equals 0. And now you can plug this into the quadratic formula or use whatever technique you use. Here we can factorise it in order to solve for r. So we see that the solutions are r is 2/3 or r is 1. But as we noted earlier, in order for the sum to infinity of a geometric progression to exist, so that sum doesn't diverge, we must have the absolute value of r strictly less than 1. So therefore the value r equals 1 doesn't make any sense. So we know that r is equal to 2/3. Okay, now that we've found the value for r, we need to answer the question, which is to find the first term of the sequences, which we've called a. So we need to use the value of r and our equations in order to find a. So let's move on to a new page and do that. Okay, so here are the 6 options given in the question, and we want to find a, and we have the equation which we call equation 3, a over 1 minus r equals 12, and we've just solved that r is equal to 2/3. So if we multiply this equation up, we see that a is equal to 12 times by 1 minus r. If we plug in r as 2/3, that's just 12 times a third, which is 4. So we therefore see that the answer is D.